In today's video, I will explain what a force compliance device is and how to choose the one that is right for your application. A PushCorp compliance device applies a consistent force, allowing for highly repeatable surface finishes. This technology is a closed-loop system that works independently of the robot. Unlike force-torque sensors and through-the-arm compliance, our device does not have to compensate for the mass of the robot arm. Instead, we only deal with the weight on the end of the sliding carriage. This makes our equipment more accurate, precise, and easier to use than any other force compliance on the market. This is critical when dealing with material removal applications, where consistency is key to achieving a beautiful surface finish. PushCorp's force compliance devices feature a sliding carriage which has limits to create a linear stroke ranging from 20 to 40 millimeters. Within this stroke, constant force is maintained. This makes programming and accounting for part variability a breeze. PushCorp's force compliance devices come in a variety of sizes that can apply as little as 1 Newton for light applications, all the way up to 1100 Newtons for heavy-duty applications. There are 2 main driving factors for choosing the right force compliance device. They are the part geometry and the weight of your process equipment. For applications with flat or prismatic parts, our passive tools are most commonly used. They rely on external, customer-supplied air pressure regulators to set the applied force. This means that every time a new orientation is programmed, the supply pressure must change in order to maintain a constant force. This is why our Active series is the go-to for application with curved parts. These tools utilize internal closed-loop feedback control along with internal force, acceleration, and position sensors to accurately apply a desired force. This accurate force is maintained over contours in any orientation. Just tell it what force you want and an active tool will apply it up, down, sideways, or any orientation in between. Using a robot controller or PLC, you can communicate with the active tools using the FCU Flex controller. Most customers use either the standard 24-volt digital interface or the optional field bus protocols. Before an active force compliance device can apply an accurate force, an automatic weigh procedure is performed. Once the tool knows how much it weighs, it can compensate for gravity and regulate its supply pressure to maintain a specific force. The passive equipment requires the user to calculate the pressure needed based on a formula. The variables required are the payload weight, the angle of the equipment relative to gravity, and the desired force. The following videos show a side-by-side comparison of the 2 technologies. The active tool knows the process equipment's weight and is varying the amount of pressure to maintain constant contact and a constant force. The passive tool is set to a single pressure using an external regulator. As it rotates around the part, it cannot compensate for gravity. Therefore, when it gets to a certain angle, it loses contact since there is not enough air pressure to lift the tool. The second driving factor is the weight of the process equipment. For example, our STC 1515 is a 15,000 RPM, 15 horsepower spindle that weighs 30 kilograms. This would be too heavy for our AFD 310, which can lift with a maximum payload weight of 27.2 kilograms. The next size up would be our AFD 620, which can lift 52.2 kilograms with a max force of 511 newtons. This makes it a great pairing for the 1515. If the application will have impact loads or high forces, our AFD 1240 is our largest active force compliance device. It also features the heaviest duty bearings in its class. Lastly, there's several different mounting configurations. There's the vertical, horizontal, and the bench mount. For part and hand applications, where you're bringing the part to the process equipment, the compliance device does not need to change orientation. This means that the active tooling is not necessary and is offered with our passive line. This is denoted with a -3 at the end of the part number. The vertical and horizontal mounting configurations are offered for both passive and active. The main difference is how the equipment will pivot as the robot rotates. Ultimately, choose between the two will come down to your part geometry and how the part is fixtured. The vertical mount has a -1 in the part number, and the horizontal, which is the most common version, is denoted with a -2. If you like this video, please make sure to subscribe and turn on your notifications to stay up to date with our latest demos. If you are new to PushCorp, click over to our video tab to check out all of our robotic material removal applications. Thanks, and see you next time.